With example 2, we're asked to graph the function y equals negative 3 over x and determine if the function is linear or nonlinear. So I made a table here from negative 5 to 5 as instructed in the directions for the problem. And we'll go ahead and just go through and do each one. When x equals negative 5, y equals negative 3 divided by negative 5, which equals 3/5, or 6/10. When x equals negative 4, it'd be negative 3 over negative 4, which equals 3/4. Negative 3 is negative 3 over negative 3, which equals 1. Negative 2 is negative 3 over negative 2, which equals 3/2. Negative 1 is negative 3 over negative 1, which equals 3. 0 is undefined. And the reason for that is because we have 0 in the denominator. Negative 3 divided by 0 is undefined. At 1, it's negative 3 divided by 1, which equals negative 3. At 2, it's negative 3 divided by 2, which equals negative 3/2. And we should notice here that it's just going to be the opposite of what it was on the negative side. So at 3, it's going to be negative 1. At 4, it's going to be negative 3/4, and at 5, it's going to be negative 3/5. So we have here, I'll go ahead and make tick marks going this way as well. We'll make each one of these 1/2, and each one of these 1/2. So at negative 5, we'd be, here's negative 5, and at negative 5, we're at 3/5. So we're right about here. At negative 4, we are at 3/4, which is right about here. Here's negative 4 here, negative 3, negative 2, negative 1. And at 0, it's undefined. So we can't put a mark there. What we'll learn later on when we study functions in greater detail, later on with rational functions like this, when we have an undefined value in the denominator, there's going to be a vertical, imaginary, or invisible line that the curve will never touch. At 1, we're at negative 3. 2, we're at negative 3/2, or negative 1.5. 3, we're at negative 1. At 4, we're at negative 3/4. And at 5, we're at negative 3/5, which is going to be right about here. And if we connect those dots with a smooth curve, or at least as well as someone who is not artistic, such as myself, we end up with this curve here, which is a basic shape for a rational function where we have a variable term in the denominator. And if you notice, it's never going to touch the x-axis either. The further we go ahead, like if we went to 10, it'd be negative 3/10. At 100, it'd be negative 3/100. So it's going to get closer and closer to the x-axis, but it's never going to get there. So we're asked, is the function linear or nonlinear? Well, it's obviously nonlinear. It's not a line. And again, that is the nature of a rational function such as this, and we'll learn about that in later math courses. Right now, all we need to recognize is we graph these points, connected them with a smooth curve. It is not a line, and therefore it is nonlinear.